Alright, so here we are playing with some valve springs, and let me give you some more tech info here. See, we have the locators. That's a standard locator with no step. Here's a step locator. When you have dual springs, you get a little bit more pressure out of there. And then all of our retainers have a step. Okay, so when you're measuring your valve spring, you actually want to put the entire spring on the locator and the retainer, and then stick it in your spring compressor. So what you want to do is you want to measure the thickness of this, the outermost edge, which is 62, and you want to measure the thickness of, the retainer is 62, that's 62, and you want to measure the locator, which is 61. That's the combination I have right here on this head. And then you put them on the compressor and you do backwards math. Okay, you add 127 to your closed and your open, so it goes from 1688 to 1815, and then I'm just going to go max open, which is 1.16, add it to that, so that's 1.296. Check my math, hopefully I'm right. I'll check it again once I'm done doing the video. And I ran into coil bind on the inner spring, and of course it's sleeping now, so let me wake it up. There it is, it's awake. Let's see where it binds. It binds at 1377. I have to go to 1296, and you can see that's 150 pounds of pressure. So let me show you that it's in bind. That's in bind. That's it. So of course it should be installed before bind. So now this number's no good. So if I didn't account for this inner spring and I just played with the outer spring and I measured it without the retainers on it, all these guys would be set up at coil bind on the inside spring. It might not coil bind because you lose it in the rockers and you lose it in the push rod because there's deflection. But you can't build a performance engine on that. You mathematically have to have a safety net built in. How are we going to do that? We're going to change one of these components. So we're going to take this one out of the equation. It has a step, and we're going to use the one without the step. And then I can use this one, or this one, or this one. Well, these are black and one of those is silver. What's the difference? Well, these are steel and these are tool steel. So these are really light and these are about, I think, well, let's walk over to scale and we'll see how light they are. Right, so this guy's 21.5 grams. He's slightly lighter, 17.5 grams. And 16.5 grams. So 16.5 grams versus 17.5 grams versus 21.5 grams. This is a heavy guy. Don't want to use that guy. These guys are pretty expensive. These guys are more affordable. You're going to chase a gram. But we're building a performance engine. So yeah, we're going to chase a gram. So those are the details you got to pay attention to. If you miss them, this thing's not going to want to rev, and or it's going to break parts. So we're going to go with these. We're going to lose a little bit of spring pressure, but we're going to have our valve train be as light as possible. Our open pressures are going to be just a skosh under 200. Our closed pressures are going to be a skosh under 200, and our open pressures are going to be right around 400. And this motor should rev to the moon, no problem at all. So hopefully that helps somebody, because ask me how I found that out the hard way. So that's the inner spring, and you can see that how I set it up. Like so. So now it's going to be like so. I'll put that back in the compressor and we'll see where the coil bomb moves to. Moves to 120. So that gives me 96 thousandths. I'm good. I'll run that. Okay, so we'll have to run the non-stepped retainers, and these stepped retainers are not the best things in sliced bread. They are going in the we will not use pile. So there we go.